So to solve this equation, I want to first factor if I can, because I'm trying to think about where this thing, again, I'm trying to take this and think of that equaling y, and I'm trying to graph that. And in order to graph something like that, two-dimensional graphing, I want to factor it to find the zeros. And zeros are really what I need after all, because I'm saying I want to know when that's greater than 0. Okay, so to factor, to do this, you could either use synthetic division, or you could literally just put it in a graphing calculator and look at it in the graphing calculator if they allow you to use it. Or what they expect you to do for something like this is to factor by grouping. So if I group these first two and these last two, I notice that I can factor out an x squared out of these two, and I can factor negative 25 out of those two, and when I do that, I'll be left with the same thing, namely x plus 3. And this one, if I take it out, I'll also be left with x plus 3. And now I can factor further. This and this have what factor in common? They both are being multiplied by what?
X plus 3.
Right, so if I take that x plus 3 out, I'll be left with x squared here and minus 25 here. And now I can factor this further, because it's the difference of perfect squares, x plus 5 and x minus 5. Remember that? So there's my equation. And now I can more easily tell that my zeros are going to be at negative 3, negative 5, and positive 5. And now when I look at the graph, I'll just try to squeeze it in down here. Negative 5, negative 3, and positive 5. What's this graph got to look like? Since it's positive leading coefficient, if these are my 3 zeros, down on the left, up on the right, and which means it has to go through, and like that. So where is it positive? See how it said, where is it positive? Well, this value is positive here, and also all of that. So there. So it's positive between negative 5 and 3, negative 3 inclusive, and then positive 5 inclusive to infinity. And there's your answer. Let's do another one. Now this is a rational function. So remember, with rational functions, again, I personally prefer that you can do a sign analysis, but I personally prefer just graphing it. Since you know how to do this anyway, let's just graph this, and then let's find out on the graph where it's bigger than 0. So I'm literally thinking of this as that equation. I'm trying to graph it, and then I'm going to find out when it's positive or greater than 0. So if you remember what I do for this, the denominator, where the denominator equals 0, are my vertical asymptotes, and that happens at negative 5. So here's a vertical asymptote, and the horizontal asymptote, since the degrees are the same, the top and bottom are both degree 1, it's the ratio of leading coefficients, which means 1 over 1. So y equals 1 is my horizontal asymptote. And then looking for my zeros, I find my zeros by plugging the numerator equal to 0. So x minus 2 equals 0 means x equals 2. That's one of my zeros. X equals 2 is one of my zeros. So there's one of my zeros. And my y-intercept I could find by plugging in 0 for x. And now we get negative 2/5, which makes sense. It's going to go through negative 2/5 right there. So my graph is going to do this, right? And then what has to happen over here to the left? What has to happen over here? It's either above or below that horizontal asymptote. How do I know that it's going to be here? Nope. Why do I know it's got to be above? Because if it was below, not because of the coefficient, because if it was below, what would I have? Another what? I'd have another x-intercept. But how many x-intercepts do I have? X-intercepts. I only have one x-intercept, because the numerator, x minus 2, when I set that, that's the only way you get x-intercepts, by setting the numerator equal to 0. Okay, so there's my graph. Now let's answer the question. where is that graph greater than or equal to 0? All the way here, but not including that 5 because it's an asymptote, right? And then from here to the right. So what's my answer? X is an element of negative infinity to negative 5, not including it, union positive, what was that?
2.
Positive 2. Oops, am I including positive 2?
Yes.
Yeah, so I have to make that a closed bracket. Positive 2 to infinity. And those are all the places where that graph is positive.